6.6, solving radical equations. This is where we kind of wrap up our entire unit on radicals. We're done with graphing. All that's left is solving for x in a radical equation. And kind of the same ideas that you're used to by now. We're going to try to get x by itself. The new ideas are we're going to raise both sides to a certain power. If it's a square root, we raise to the second power. If it's a cube root, we raise to the third power, and so on. Then we solve using techniques that we already know. So let's dive right in. I see a cube root. If I want to get rid of it, I raise both sides to the third. If you're not sure you believe me, let me show you why. Cube root really means to the 1/3 power. If we raise that to the third power, what do these numbers do? We multiply. 1/3 times 3 is 1. So we get 2x plus 7 equals 27. All that's left now is solving for x using old techniques. And we're done. Not much to the basic problems. They do get harder. At this point, you can pause the video, try these on your own, or do them later. All right, go ahead and pause the video, read over this problem, make sure you understand what's going on before we start doing anything with numbers. We're certainly going to want a calculator for this one. Decimals and big numbers, not a great combination for doing things without a calculator. But you can see in this problem, we're told the wind velocity, so you can plug that number in. We want to solve for p. Before we square both sides, we should get rid of that 6.3. And we do that using old techniques. Just divide both sides by 6.3. We end up with 8.7 equals square root of 1013 minus p. At this point, I think you should be totally fine on your own. Go ahead and try this, and then check in with me. Don't forget your units at the end. The air pressure is 938.2 millibars when the velocity, the wind's velocity, is 54.5 meters per second. At this point, you can pause the video and try this on your own, or you can do that later. This one looks a little different. We don't have a square root or a cube root that we're dealing with. We have a fractional exponent. So let's take a look at how we're going to deal with any fractional exponent. First thing you're going to do is get rid of that 4, because the 2/3 is not affecting the 4. Divide both sides by 4. The way we're going to get rid of that 2/3 exponent is really kind of elegant. What can we multiply 2/3 by to make that fraction of 1 instead? Because we want to get x down here. We just flip the fraction. Of course, 9 to the 3/2 is not simplified, so we go through some old steps to simplify that. If you don't recall, I'll walk you through them. First, we write that as 9 to the 1/2 cubed. We know what 9 to the 1/2 is. That means the square root of 9, which is 3 to the 3rd, is 27. Done. Same idea kind of on example 4. We see that 3/4. The first thing that should maybe enter your mind is that we're going to have to raise this to the 4/3 power. But there is something you should do before you raise both sides to the 4/3 power. Try to figure out what that is, and then go through and do the whole problem and check in with my steps, see if you get the same answer. I think the hardest part in this problem is dealing with the 8 to the 4/3. Notice, so far, this has always been something nice. If it would have said something like 9 to the 1/3, we would not have been able to simplify that. We would have had to get a decimal answer. But don't get a decimal answer if you can avoid it. Next up, you could try these on your own, or you can do that later. Next two examples are when we have some extraneous solutions. The reason we're going to get an extraneous solution is because we're squaring and changing this to an x squared somewhere in the problem. Let's look at what I mean. Most of the time on the example so far, when we squared both sides, one side had a number, one side had a variable. We can't really do that this time. Best we can do is square both sides. And all of a sudden we have a quadratic, which is going to get us two answers. Sometimes one of those answers is extraneous, meaning it doesn't actually work. So go ahead and try to solve this quadratic on your own. And then before we check our answers, we'll check in. Hint, you want one side to equal 0, at which point you can try Clinton magic. If Clinton magic doesn't work, you have to fall back on the quadratic formula. Okay, so we get our two answers, 7 and -2. Now we have to check them by plugging 7 into the original equation. Let's see what happens. 7 plus 1 is 8. 7 times 7 is 49, plus 15, so we get 8 equals square root of 64. That's true, so 7 works. So 7 is good. That doesn't necessarily mean that -2 is bad, it just might be. So we're going to have to check the -2 also. We plug that in, we get -2 plus 1 equals square root of -14 plus 15. So we get -1 equals square root of 1. That's not quite right. So we have to throw that answer away. A common mistake that students make is throwing away the negative sign, negative answer, just because they think negative's not going to work. That's not always true. You've got to plug the numbers in and see which one works. In fact, I believe the next example, the negative answer is going to be the one that works. So let's take a look. Okay, this is a beast of a problem. We're going to have to square both sides twice. I wouldn't expect you to know that just by looking at it, but you'll see why as we go through. Once we square both sides the first time, that's not even that easy to do. The right-hand side is pretty nice. The left-hand side is a little complicated. In fact, off to the side, let's look at what we're really doing. It's worth doing a side problem, I think. I'm using FOIL, or distributive property. Square root of x plus 2 times the square root of x plus 2. That's nice because it's the same thing on the inside both times, just x plus 2. Plus square root of x plus 2 times 1. Square root of x plus 2. Plus 1 times the square root of x plus 2. Plus 1. So if you notice, we got some like terms here. We really end up with x plus 2 square root of x plus 1. Sorry, square root of x plus 2 plus 3. So, does that look messy enough? I think so. We're going to still need to get rid of that square root. You might think that this is getting us nowhere, but we actually got somewhere. If you look back at the original problem, we had 2 square roots in there. Now we're down to 1. So this is actually simpler than the original. Before we square both sides again, we want to isolate the square root. We want to get that by itself, so when we square both sides, it's nice. So I'll do that by subtracting 3 from both sides, which actually turns out really nice. And I'll subtract x from both sides, which isn't as nice, but it's still not too bad. I probably want to get rid of that 2 in front before I square both sides. It's not required, but it makes the number smaller. Now I can square both sides again. So we do that and we get x plus 2 equals positive x squared. At this point, we get to solve for x using Clinton magic or quadratic formula. Hopefully Clinton magic works. And it does. And we can't stop there. You have to go through and plug those two numbers, 2 and -1, into the original. So this is our checking our answer piece. Go Go ahead and check both of those answers on your own, 2 and -1. See if one works, see if both work, see if neither work. When we check our solutions, we see that plugging in 2 does not work. 3 does not equal 1. But when we plug in -1, it does work. So our only actual solution is x equals -1. Checking for extraneous solutions is something we're going to be doing all through the next chapter as well. So get used to that idea. If you always check your work, then this should just be no more than an afterthought. If you're not in the habit of checking your work, start getting into that habit. At this point, you can pause the video and try these on your own. Other than that, we are done with chapter 6.